Imagine looking up at a dark sky where a huge blue-green ice giant fills the view, wrapped in shimmering rings. Tonight we'll travel there in our minds and explore how such a frozen giant world with rings could really work. Our ice giant is similar to Uranus or Neptune, mostly icy materials like water, ammonia, and methane, mixed with hydrogen and helium. Thick, stormy clouds swirl in fast winds, hiding a deep, hot interior under the freezing outer layers. Now add a wide ring system. Dusty ice chunks circle the planet, from tiny grains to boulders the size of houses. These pieces constantly collide, chip apart, and spread into thin, glowing bands that trace perfect loops around the world. Moons act like gardeners of the rings. Small, icy moons orbit nearby, their gravity shaping gaps and sharp edges. When they pass through dusty regions, they stir waves and ripples, carving patterns that drift slowly around the giant planet. Seen from the planet's surface, if it had a solid one, the rings might stretch across the sky like glowing arcs. As the planet rotates, the rings could rise and set, casting moving stripes of soft light and shadow over icy plains and dark valleys. Seasons on a tilted ice giant with rings would be dramatic. When its axis leans, one hemisphere gets more ring-reflected light. Polar regions might glow faintly at night as sunlight bounces off the rings and rains down like gentle, colored daylight. Far above the clouds, tiny ice crystals drift from the rings into the upper atmosphere. As they fall, they may help create thin, high hazes. The sunlight they scatter could tint sunsets in strange shades of teal, violet, and pale, silvery blue. Imagining this ice giant world with rings helps us think about real planets beyond our solar system. By studying light and gravity from afar, detect such ringed ice giants for real, turning today's dream into tomorrow's discovery.